Okay, so today we are doing lesson number 5, which is reciprocal functions. And so in this unit, we've talked about absolute values the entire time. And today we finally get to talk about the other half, the reciprocal functions. Okay? And so there isn't a really strong connection between absolute values and reciprocal functions. So this lesson is kind of like one that's just been stuck on the end. So we actually don't have to use the information from absolute values for this, which is kind of nice if you found that kind of difficult. So what is a reciprocal? So when we did the rational equations and expressions, we talked about taking the reciprocal when you divide, which is just when you flip it, right? So that's the same thing here. So if we think of this as being y is equal to x squared minus 5, which is the same as x squared minus 5 over 1, right? When we take the reciprocal, all we do is flip it. So it always becomes 1 over the function. Okay? So exactly, what does that do? That does a lot of things when we're graphing. So if we look here, when we were doing our rational expressions and we were talking about non-permissibles, we talked about asymptotes, right? So where do we find asymptotes? Does anyone remember? Exactly. So in our original graph, like we have here, our x-intercept is at -3, right? And we find that just the same way we always have. We go, okay, well, set the equation to 0, find what x equals. Okay? In the reciprocal function, that point becomes an asymptote. Right there. Okay? Exactly. So if we were to look at this, and then someone said, or I was to ask, what's the non-permissible? Everyone would remember that, oh, the non-permissible is when the denominator is equal to 0. So our non-permissible is -3. Exactly. You only have asymptotes when you have a rational. No. So that's a good question. These lines are actual graph. This will continue forever and ever and get closer and closer to -3. Like this is, yeah, and it'll actually get closer and closer and closer and closer to -3, but it will never cross it. It'll never touch it. Okay? And that makes sense because we know that we cannot have the point 1 over 0, right? Like, this is like grade 5 stuff that you can't divide by 0. But I'll explain it to you later. Okay? So we know that we cannot divide by 0, so x can never be -3 because that would make our equation dividing by 0. So the equation will get closer and closer to -3, but it will never cross it. Yes, Josh? That's a good question, because it looks like we have one here as well. And yes, we do. Well, in my graph it does, but. Okay, so we have this one at -3, and this one at y is equal to 0. Okay? So, before we talk about that, we're going to talk about a few other things. So what I'm going to do is I'm going to draw our original graph and our reciprocal graph on the same one. So I'll go like this. Yeah, never touches -3. No? Yeah, I can. So, like for example, no, so like for example here, the graph would go to like, okay, here it's at 2, here it's maybe 2.5, 2.9, and then say 2.99, 2.999, 2.99999, and it'll just continue on and on, but it'll never get to 3. Okay? Then it would be undefined, because we know when x is -3, we don't have a graph. Okay? So some other things that we have to notice when we're doing these reciprocal functions is we notice that, oh, if we put our original and our reciprocal on the same graph, like we have here, we notice that it intersects at 2 points. Okay? And if we look at that, we can say, oh, well, let's look at where it intercepts. So we'll go like this. So it intercepts at, can someone tell me? Yeah, it intercepts at y is equal to 1 and y is equal to negative 1. And this is always true. Always. If your original graph touches your reciprocal graph at all, it will always be at 1 and negative 1. No. Because if I take the reciprocal of negative 2, okay, I get negative 1/2. If I take the reciprocal of 1, I get 1. Okay, so that point at 1 and negative 1, if you have that point on your original graph anywhere, it's going to be the same point on the reciprocal graph. Okay, so I'm kind of trying to explain this all with a picture, and then we're going to be taking notes on it too. So don't worry too much about writing it all down yet. Okay, so some other things we get to think about is our Y-intercepts. So here we can see that our Y-intercept is at 3. So where would you guess the Y-intercept of our reciprocal would be at? That's the reflection, right? So if it's positive, it stays positive in reciprocal graphs. But what's the reciprocal of 3? Exactly. So where we have 3 here, we have 1/3 here. Okay? So that's true of all of the y values on our entire graph. Okay? So, yeah, write out our Y-intercept. Yeah. The Y-intercept here. And then it becomes 1/3 on our new graph. Right there. Right here. Okay? So, some other things we get to think about. Okay? So, on our other one, I'm going to go like this. No, it's not very good. So on our other one, when we're drawing a reciprocal, because we will get questions where it's like, here's the original, draw the reciprocal graph. You want to map out your asymptotes and map out your invariant points. So we say, okay, we know at our asymptote, our reciprocal graph will never touch that. And we know at our points at 1 and negative 1, our graph will touch those points. Okay? So then we get to say, okay, when we look at this part, we say, well, x here is getting bigger and bigger and bigger and bigger. And we could continue this line here forever and ever, and x would just keep getting bigger and bigger, right? Exactly. So if we say, think of it like, okay, x is getting close to infinity. That means the reciprocal of it is getting close to the reciprocal of infinity. And so as this number here gets bigger and bigger, what happens to our total? Okay, so I can even show you this on a calculator. So we say, okay, let's say like this. We'll go, okay, 1 divided by 10. Okay, so that's say x is 10. Now let's say x is 100. So we'll go 1 divided by 100 for our reciprocal. Okay, so let's say x is continued on to 1,000,000. Okay, So now I'm going to go, what do we notice about our reciprocals? They're getting smaller and smaller and smaller, right? So that means 1 times 10 to the negative 6. So it's like 0.0000001. Okay, so as our x here gets bigger and bigger and bigger and bigger, our reciprocal gets smaller and smaller and smaller and smaller. So that means for all of these points here, where x is getting bigger and bigger, our reciprocal is getting smaller and smaller. So it's getting closer and closer and closer to 0. Okay? But we have an asymptote at 0. So we know it never actually touches 0. And if we think about it, we say, okay, well, if x can get bigger and bigger and bigger all the way to infinity, then that means we're never quite going to get to 0 when we take the reciprocal, right? Because there's always something bigger that we can make x to make our reciprocal smaller. Okay? For this part here, we can think, okay, well, if we think of this part as saying, well, x is getting bigger, so it's getting farther away from the x-axis. With this part, our x is getting closer to the x-axis. Okay? It's coming right down to 0. So in our reciprocal, as x gets closer and closer to 0, what's going to happen with our reciprocal? In the original, if x is getting smaller. Exactly. So I can show that on the calculator too. So if x is something really big, like that, when I take the reciprocal, our answer is going to be very small. Okay? When x is something really small, like that, when I take the reciprocal, our answer gets very big. Okay? So for this part here, our x is getting smaller, and so on our reciprocal, our x is going to get bigger and bigger and bigger and bigger. And it'll continue on to infinity, getting closer and closer and closer to negative 3. Okay? And then for the negative side, yes? So these green lines here are at y is equal to 1 and y is equal to negative 1, because we know that this is like the connection point between the two graphs. Okay? If your original graph touches one of those points, then your reciprocal will as well. If your original doesn't touch 1 or negative 1, your reciprocal won't. Okay? And then so for the negative, we can say the same is true. We can say, okay, well, here x is getting smaller and smaller and smaller all the way to negative infinity. So we can say it's getting bigger, but in the negative, right? So we're going to say the same thing. We say, okay, well, as x gets bigger towards infinity or negative infinity, it's going to get smaller. And this one, as x gets closer to 0. So for this one, Josh, like we said, x is getting bigger and bigger, but in the negative direction. So it's going to get smaller and smaller and smaller in the negative direction. And here, as x gets closer and closer to 0, in the reciprocal, it's going to get farther and farther away from 0. Okay, so let's take some notes. So they say, they ask for the y-intercept in our original graph. So we can look at it and say, okay, in our original, our y-intercept is at 3. Okay, then they say, what is the y-intercept of the reciprocal graph? And we talked about how when you do that, you just take the reciprocal of your y-intercept. We got negative, or we got positive 1/3. Because if it's positive in the original, it's going to stay positive in the reciprocal. Okay? Then we found, okay, well, our x-intercept is at negative 3 in the original. So the equation for the vertical asymptote in our reciprocal is x is equal to negative 3. Okay? So wherever you have x-intercepts in your reciprocal, you will have a vertical asymptote. Okay. So they say the coordinates of the 2 points which appear on both the graph are at y is equal to 1 and y is equal to -1. So if we look at our graph, we can say, okay, well, that's at -2 and 1 and -4 and -1. Okay, and these points we call invariant points, okay, because they don't change, right? And then the horizontal asymptote is y is equal to 0. So the horizontal is found at 0, and the vertical asymptote is found where your x-intercepts are. Okay. Yep, of the vertical asymptote is also negative. Yeah. Because the x-intercept is where that denominator would equal 0, right? Okay, so it's like our non-permissibles. Okay? So they say, this is basically explains it. They say when the function equals 0, so aka the x-intercept, the graph of the reciprocal has a vertical asymptote. Okay? And then they say, as the graph approaches negative infinity or positive infinity, so as x gets bigger and bigger and bigger in either the positive or the negative direction, the graph of the reciprocal gets closer and closer to the horizontal asymptote. And you can write aka 0. Okay? Okay, and even at the bottom for yourself, you can write as the function gets bigger and bigger, the reciprocal gets smaller and smaller, or closer to 0. Parts of it we go through faster. Okay? Okay, so if we flip the page, so with this one, they've drawn us our original and our reciprocal. So the first things we're going to do is we're going to say, okay, let's figure out where our asymptotes are. So in our original, we have our x-intercepts at 2 and -2. And if we look at the graph, we can even see that, say, okay, when x is 2, we get 0, so an x-intercept. And in the reciprocal, it's undefined, which means